All right, good morning, folks. I'll give folks a chance to sit down, then we'll get started. Can everybody hear me okay? Way out on my east side, not so many on the west side. Okay. Well, thanks for making your way over to this room. If you were courageous enough to trek over to this side of the building, you really want to hear what we have to say, so we will make it good. My name is Sue Dougherty. I work at NYSERDA on the Community Thermal Network team, which is part of the Clean and Resilient Buildings team. Thank you for joining us for this presentation on NYSERDA's large-scale thermal program. I'm joined by a couple other panelists, Mike Rohan from Northwell Health and Scott DeHollander from Cornell AgriTech. And when I'm towards the end of my slides, I'll give a more formal introduction of their background and their roles at their organizations. And you can see that they're going to provide you a really great presentation. After I give, like I said, after I give an overview, I'll cue them up to come up and give their presentations. So for today's agenda, I'll be talking about our large-scale thermal program, also known as Program Opportunity Notice 5614. I'll get into the details of what that is. It's funding support for design of large-scale thermal projects, but it also includes some other work that we're doing on the Community Thermal Network team, some complementary market development activities. And then after I'm done talking, Mike and Scott will come up and they'll provide some campus owner, facility manager experiences and perspectives on developing large-scale thermal projects. We've often had, in past presentations, designers or solution providers come up and talk about the projects that they're designing and giving their expert insights onto it. For this presentation, we decided we'd bring in some of the folks who are embedded right in these facilities that are helping advance these projects to give their honest perspectives on it, some of the challenges, how it's going, how this fits into their broader decarbonization planning. And so they'll provide some project examples and some areas that we're collaborating with them through our large-scale thermal program. And then they'll give some factors and talk about things that help enable the development of these large-scale thermal systems. After that, we've reserved some time for some Q&A, as long as we all stay within our timelines here. And so I'll ask that you hold your questions to the end, and then we'll pass around microphones so folks can chime in and ask any questions that they have for the presenters. Okay, so this slide is meant to provide some context about the challenge that we have ahead of us. In Doreen Harris's open remarks this morning, she talked about the number of buildings that we have to decarbonize in New York State. We have over 6 million buildings that eventually have to be decarbonized, and in order to do that, we are evolving our approaches at NYSERDA, and we have been for some time, to continue to address these buildings at scale. So that's large buildings like the ones we see all around us, that's groups of buildings on a campus, and that's eventually entire communities. And an example of how we've applied this approach in the past is through our Community Heat Pump Systems program, which Doreen also discussed a bit this morning, which we launched back in 2021. It ran for 10 funding rounds and closed at the end of 2023. And through that program, we were able to support a variety of thermal energy network projects, and I'll give some stats on the next slide. But going forward, back in June, we launched PON 5614, not to be confused with 4614. That is a coincidence. We apologize for the similarity in numbers. But hopefully that helps with branding. Just remember 614 and you have found the Community Thermal Network team. But going forward, our plan is to continue to help advance these projects through the design phase. So like I said, here are some stats on the Community Heat Pump System program, which ran for 10 funding rounds. We were able to fund projects at over 50 sites all throughout New York State, all the way up from Saranac Lake, all the way down to the bottom of New York City. And those projects have been funded at various different stages from feasibility through construction. And while we already have 12 projects that have advanced to design and 6 that have advanced to construction, we have about 48 feasibility studies in the pipeline that we're helping to nurture and move forward to become shovel-ready design projects. What we noticed through our involvement in these projects to date is that the easiest near-term opportunities for these types of projects are single-owner campuses or single-owner project sites like colleges and universities, medical campuses, of which I have some representation here today to talk about some of their projects, and then other campus-type projects like multifamily facilities and commercial real estate or large commercial buildings. So we're going to continue to support these types of projects through feasibility, and with this new funding opportunity, help them advance through the design phase. So while this slide presents some examples of the types of projects that we're working with going forward, it is not an exhaustive list. Our focus is on single-owner projects, but like I said, that's really more because that's the easiest near-term opportunity. It's easier for coordination and construction logistics, easier for financing, and more straightforward ownership structures. And through PON 5614, we will help the projects that came in through 4614 at the feasibility stage, as well as projects that are going through FlexTech, and then projects that are funded through some other means to complete a feasibility study. They can come to our program and propose for design funding, and if they have a great viable case that's technically and economically feasible, then our intent is to help move them forward through the full engineering design phase. And we continue to support feasibility studies at NYSERDA through our FlexTech program. So PON 4192 is still open to offer cost share for feasibility studies that are just getting started. And this is 5614 right here. Our intent is to continue to fund replicable large-scale thermal systems at the design phase that significantly reduce greenhouse gas emissions from heating, cooling, and domestic hot water. And a slight difference between the projects we supported in 4614 and what we're supporting going forward in 5614 is that we've brought in the scope a bit in terms of what we're supporting, and that was through insights that we saw in FlexTech as well as 4614. We want to be able to not just address networked style projects, but large-scale projects in general, whether that's a large single building or a cluster of buildings on a single campus or on contiguous properties. So as long as a project meets these minimum thresholds for a single building of at least 150,000 square feet of space, or at least 250,000 square feet for multiple buildings, networked or non-networked, then they would be eligible for our program. We do have slightly different funding levels for existing buildings and for new construction. So existing building projects, because they're a bit tougher to tackle than a clean slate, they can get up to $500,000 of cost-shared design funding, and for new construction projects, they can get up to $300,000 of design funding. We just closed our first round due date at the end of last month. We're really excited. Doreen mentioned a bit about the response that we got to that program. We are in the proposal evaluation phase of our selection process, and we're excited to go through those and find the viable projects that we want to help move forward to design. And we'll be working with those selected projects going forward to execute contracts and get the design work kicked off in probably by early 2025. We're open right now for round 2. The due date for round 2 projects is January 30th of next year. So maybe everybody should run home after this conference and start working on their designs, because we're just a few months away from that. And we're looking forward to the next batch of projects that we get in round 2. There is a cost share requirement. So project proposers must offer at least 50% cost share when submitting a proposal to PON 5614. All right, and I mentioned we're also doing some other complementary market development activities to go alongside of the design funding that we're helping to advance these projects. So RFQL 5856 was issued around the same time as round 1 of 5614. And the intent of that RFQL is to build a pool of solution providers that we can call upon to help the marketplace in several different ways. And these bullets here list some of the ways with supply chain development, offering technical services for design and commissioning, helping us with our program design and reviewing projects, and helping with the, helping with review the deliverables that we get through the contracts for each of these 5614 projects, as well as data collection and analysis. So we want all of this information to be ingested, digested, and then we want to be able to disseminate all of the learnings with the marketplace. So these, this pool of solution providers would also be helping with that activity. And I listed here also some examples of areas where they could help. We will continue to do outreach to project developers and building owners to continue to build our pipeline of projects. Some other areas where we might use this pool of providers is through researching energy storage and waste heat recovery opportunities in New York State, which is an important focus area for our team and for NYSERDA in general to help decarbonize buildings. And then I listed a couple of other opportunities that we may pursue going forward. So that's a bit about what we've done over the past few years and what we're planning to do going forward to support large-scale thermal systems. You can find more about our program on this link here. We have a fancy QR code, so if you're close enough to a screen or you want to jog over to one right now for the folks in the middle, you can take a picture of this or you can plug this URL into your phone and learn more about the large-scale thermal program. On this website, you'll find fact sheets for the projects that we have funded in the past, and like I said, we'll continue to populate that website with the information that we're learning and with more information about the projects that we're funding going forward. My contact information is here, as well as our team's district thermal email inbox, so you'll reach one of us if you submit an email there, and we'll get back to you, and we'll look forward to corresponding with you about how we can work together on some of these projects. So I am, in a moment here, going to turn over the microphone to Mike from Northwell Health, but I'm just going to give some background on our presenters because I know that you'll be pretty pumped, as I am, about some of the information that they're going to be able to share with you. So I don't have this memorized. I'm going to read this. But Mike has an educational background of engineering and business and over 3 decades of experience in all aspects of facilities management. He is also a member of multiple working groups for Local Law 97 to help accelerate decarbonization of buildings in New York City. He is a principal of energy and engineering at Northwell Health, which he joined in 2003, and uses his expertise to facilitate energy and infrastructure projects at a reduced expense. During this panel, Mike will discuss the approach for Northwell Health to decarbonize their facilities, and he'll share some examples of large-scale thermal projects on Northwell Health campuses located in New York City and the downstate area. All right, and I'm gonna cover Scott quick first, and then Mike, I'll ask you to jump up here. So Scott DeHollander is a professional engineer with 25 years of experience. Scott has spent the last 12 years in higher education in a power plant setting, and in a previous role, he was working at the University of Rochester and oversaw the expansion of their district hot water system and converting over 1 million square feet from steam heating. Scott is the Associate Director of Facilities at the AgriTech campus and is spearheading Cornell's $35 million conversion from steam to a geothermal energy network. During this panel, he will discuss some enabling policies and goals at the state level that are helping SUNY campuses like AgriTech to undertake large-scale thermal projects. He'll also outline the strategies he's facilitating to decarbonize buildings on the campus, which is located in Geneva, New York, up near the Finger Lakes region. Both of these panelists really represent great examples of locally vetted experts and champions for the development of large-scale thermal projects on their site. So I hope you enjoy hearing about their projects and a lot of the great work that they're doing. And Mike, I'm going to turn it over to you.
We need to have our names up front. All right, thank you all for being here. Thank you, Sue, for the introduction. And I'd like to start off with this slide in particular because that's the same exact perspective about 60 years apart. And New York City, a lot of incineration, a lot of coal firing back in the early 60s. And the skies have cleared a lot, but we don't really have 60 years to wait. We need to accelerate this transition. And I find that, what we're finding here, I find this pretty fascinating, what they mentioned this morning about how many folks are now here. And I also found it interesting that how many folks are certified, from the 4 to the 5 to the 9. But, I think we're at a really great point of accelerating a lot of good opportunities. Oh, wrong way. So we've been working, my whole career, I used to work in a refinery. And back at the beginning, we were chasing BTUs because it made economic sense. We didn't attach a carbon element to $1 at that time. But at Northwell, we have been performing carbon footprinting for 15 years. Each of our hospitals has a very detailed report. And the baseline blue bar was from '09. And you can see we've dropped quite a bit in the last few years, 15 years. But we have a long, long way to go. But now we also have more opportunities. What were the standards have drastically changed. So this depicts a pathway to net zero, and everybody can identify different opportunities here, but each one of those yellow bars is a reduction measure. We think about this from the perspective of this energy hierarchy. And I'll just back up a little bit. Thermal reengineering, I might have borrowed this from Pat up in the NYSERDA offices, I'm not sure. I was involved in some reengineering exercises, and we were discussing how do we change the typical paradigm? What do we need to do? And I thought this morning, Jens had a great example showing the simultaneous heating and cooling, the cooling tower while the steam is leaking. And how do we better balance these loads? So we took this and kind of came up with the idea of Maslow's hierarchy of needs. And how do we establish the baseline needs? The baseline needs education, behavioral change. How do we establish an energy culture? What do we do to our design standards? The design standards have gotten a lot more rigid, and we need to integrate those, especially with old buildings that need to be modified. It's easy enough to start ground up in a greenfield, but old buildings are quite a challenge. Sue alluded to the complexity of modifying a steam facility to hydronic. MSK, right here in New York City, just recently did their entire campus, $111 million in 7 years, but a very quick payback. So there's a lot of good opportunity, but how do we identify them first? And that's what we're all talking about. We have the very comprehensive energy program, and we also put our rebates and our energy savings back into a sustaining fund to allow us to develop the next group of projects. And that ties into our continuous retro-commissioning program, continuous commissioning. As we go up the hierarchy, what are the next level, the technologies that we're talking about today? Geothermal is not at all new, but there's a lot of new applications, a lot of new ways of thinking about it. And we also have examples for solar and a little green hydrogen that we're working on. Then at the pinnacle, at the net zero, at the self-actualization from Maslow, is negative emissions. How do we get to that point of balance? And potentially carbon sequestration for those very, very difficult to decarbonize loads. as well as tree planting, best opportunities that we have for negative emissions. So we're at Northwell. Now, Northwell has close to 100,000 employees, largest private employer in New York State, 27 hospitals now, and about 900 other properties. We have had an open-loop geothermal well operating since 1967. It's 400 feet deep. It's into the Lloyd Aquifer. Now, we want to stay away from the deeper aquifer, keep it pure. But we have had this project operating, and that building, for a while there was discussion, do we want to even file for Energy Star anymore? You know, it was just because of geothermal, it was a given. So it shows the impact that geothermal can have at one site, and it's a hospital. Hospitals are complex loads. So we are now working with a few folks in the room on a 1,300-ton closed loop system out toward the end of Long Island, as well as analysis at some other sites. But I think the Peconic Bay 1,300-ton has kind of opened my eyes a bit to, again, what I alluded to before about what Jens was saying, that at Glen Cove, the project that's been in place for 65 years, it's an open loop. So all we're doing is replacing our cooling towers. With the closed loop, how do we balance those loads? And the balancing, I'm finding, is quite a challenge. And but that is the interesting part, because we have a lot of complaints. Hospitals, I think everybody knows, are the largest energy users, except for some refrigeration facilities. But a lot of it's tied to our patient demands and infection prevention. So there's a lot of need for that, but there's also a lot of wasted energy right inside the building. Simultaneous heating and cooling is a major culprit. So what we're doing at Peconic Bay is a deep analysis on how do we balance those loads. And then I really appreciated this morning what he was saying about how do we get to those numbers that they were showing in the apartments in New Paltz. Another project that we have a pretty good design on right now is our second largest hospital, North Shore University Hospital. About 18 years ago, we put a loop between all of the different chillers that we have throughout the campus. Hospitals typically grow, across decades, 53 to 61 to 74 to 2000 to the latest building with the white roof. That's more noticeable. So with that loop, how do we now enhance efficiencies? We can continue to upgrade equipment, find the next best alternative, but one of the challenges we're also starting to look at is the energy grid. We're starting to look at peaks that are becoming more challenging. In this particular hospital, we do not have emergency power for all of our chillers. So in the event of an outage, how do we complement thermal storage with emergency generation? That's the resiliency managing with the sustainability. So in this case, we're looking at heat recovery chillers as well as ice chillers, and one large mass of cold water ice. And what we're looking at possibly is 6,000 tons of capacity for maybe 24 hours. So it's a large reservoir. And coupled with that, as you can see on the right hand, is we have property available. So we're looking also at geothermal. So we do have a 160-page analysis already performed, and we're at the point now, where do we go with that? How do we start to balance the thermal loads? How do we enhance efficiency? And I think that right there is a very critical element, because how do we peak shave while we're providing extra protection for our patients? Now, another project, and NYSERDA has been involved in this one for a bit, is a project at our one of our hospitals in Westchester, and we are heat recovery. And how do we get that heat around? So we are enhancing by adding a heat recovery chiller, adding an additional chiller for redundancy, but now the balancing act is following. So we're working closely on that one. We do have another hospital on Long Island, Mather. We received a $1 million rebate for thermal storage at that hospital. And recently, so we're starting to incorporate, going back to design standards, on the right-hand side, we've started incorporating heat recovery right from the basis of every single new project. So it was almost, I found out about this afterwards, it was kind of an afterthought. Oh yeah, of course, we put in an air source heat pump. We didn't put in a conventional. So I think that's also a sea change, that this is starting to become common, intuitive, as opposed to a one-off. This is an interesting one. Out in Peconic Bay, we are putting that 1,300-ton geothermal project in place. That's the edge of the North Fork. North Fork is still a lot of farming, and Northwell is committed to food as health, healthier patients with potentially food developed on campus. So with this particular case, where we have a high school recently closed, we have 22 acres that wraps around the campus. That allows us to find the space for the 1,300 tons, but we're also putting in solar. And with that solar would be some solar thermal and a greenhouse. So we're covering, starting to cross over into some of the other areas that Northwell is looking at with regard to community support, because there is opportunity to expand the project that we're looking at to our neighbors, but also food as health, central elements to our healthcare industry. Now back to peak shaving and grid integrity. We have, back in June when we had that heat wave, we started getting low voltage at some of our campuses. So we said, how do we identify this concretely? Not just like it's low voltage, our generator just kicked on, what can you do to support us, Con Ed or PSEG? So we're putting in power quality metering, but what that'll allow us to do is develop a distributed energy resource management system, or as I've indicated here, a GEB, Grid Interactive Efficient Buildings. Now the DOE has been working with this for a few years now, but I think it's not really been socialized. And how does that complement what we're talking about here with geothermal, but from the perspective of geothermal provides that thermal mass that can complement our electrical needs. So what we're developing on this is a network where we're picking up points from all of our hospitals, and we'll start to use that as the basis for grid interactive efficient buildings. So that's my last slide. Commander.
Howdy. Anyone else bummed out about the Buccaneers loss last night? Any Jets fans here? I'm going to take you up north to upstate New York. Our campus is located, as Sue mentioned, in Geneva, which is a bit of a distance from Ithaca, where our main campus is, and where most people probably think of when they think of Cornell and Ithaca. But Geneva's a beautiful place. We've got 900 acres of primarily agricultural research going on. So it's food science, food research, and entomology located in Geneva. There's also on the same site, people have in the past connected us with the New York State there is a New York State research component to the site as well, and we've been doing agriculture in this location since 1850. The heating plant was built in 1950, and it includes pretty conventional steam distribution, and a lot of our buildings date back to that 1850 as well. There's only 6 buildings on campus, and when we started considering the project, we were really strapped for, how to tackle something of the magnitude of $35 million. So what our application to NYSERDA really did was provide a spark to start attacking that through the PON 4614. This first slide is a picture inside our steam heating plant. As I mentioned, we received NYSERDA funding for, or through 4614 to evaluate our central utility plant and infrastructure. The primary goal was to find some alignment between the university's climate action plan, which had a time frame of 2035, and also the state's and SUNY's goals of 2030. So rapidly approaching. We were in meetings, and prior to submitting for the 4614, we really had no plan for meeting those greenhouse gas emission reductions. We also had a lot of infrastructure and improvements planned on campus. There's a proposed 60,000 square foot new building that's coming to campus, and that provides an influx of opportunity, as we saw it at the time that some of these things were coming together. So we were looking for some synergy between that capital project and how we were going to make this conversion. And we also were a little stressed about talking about such a large capital project, $35 million to do a conversion. So we wanted some implementation phasing to really knock those costs down. And all of those things were really made possible through the feasibility study. So here's a little bit of a slide that shows our campus. 6 million buildings in New York State that have to be converted. We're struggling and talking only about 6 here. So our campus is much smaller, certainly than the larger problem, and a lot smaller than even the challenge at the main campus of Cornell, but still a sizable campus. Including our greenhouses, we're about 600,000 square feet, and 350,000 of that is conditioned. The star indicates where our heating plant is located, and as I mentioned, there's this 60,000 square foot building that's coming to campus to house the USDA's National Grape Improvement Center. So if you like upstate New York wines, this will hopefully make them better. Also on tap is a $20 million mechanical retrofit for our food science building, and the combination of those two projects is going to bring some significant infrastructure to our campus. We also have a couple smaller projects on the horizon. There's a water system upgrade to include some sprinklers for our largest research building, Barton Lab, and then some end-of-life mechanical system refits in Hedrick and Sturtevant. So that's just an introduction of our campus layout and some of the synergy projects that we were trying to link up with. This next slide shows the system in schematic with those locations of those buildings and projects still pending. So this slide I'll repeat a couple times as I start walking through the phasing of our conversion project. But first, a slide to introduce you to what our strategies and what the mandates were that we were looking to exceed or meet. The first, the governor's executive order 166, there's two thresholds there. There's a 40% reduction for greenhouse gases by 2030 and an 80% reduction by 2050. And there's some overlap with both the SUNY directives there as well, most notably the 40% reduction by 2030. So that really kind of became the critical goal that we were trying to achieve, but we wanted to set ourselves up as we developed the phasing plan to achieve that 85% reduction as well. And in the meantime, it was through the feasibility study, it kind of acknowledged that we could do a lot to clean up our campus in terms of energy efficiency. So we've participated and are continuing to participate in that NYSEG commercial industrial rebate program. That's pretty handy. That's out there right now as well. Focuses on light bulbs and weather stripping, some enclosure stuff, but handy for older buildings like what we've got on our campus. So a step into our phasing plan here. This is our current configuration. The first slide showed inside our heating plant, it is 3 fire tube boilers, 2 700 horsepower and 1 350. We have a current annual cost of energy around $1 million, and we're burning about 67 decatherms of natural gas and using about 1,100 megawatt hours of power. Some of our buildings are hydronic heat, some of them are steam, and converting toward hot water is definitely some of the lower hanging fruit that we're trying to peel off from the project. I forgot to slip forward on some of these slides. There's some animation in the heating plant. Those are the boilers. We do have a walkable steam tunnel. And these are now highlighting buildings that have kind of the more significant refits associated with them. There's the food science building, $20 million is allocated toward the mechanical refits there, but there is some research that uses a culinary steam boiler, and that is what keeps our heating plant currently running year-round. One of the first steps to reduce our greenhouse emissions and also become more efficient was to really look at that scenario and see if we could challenge that with some electrification to be able to turn the steam processes off for a portion of the year. And then we also use steam for some autoclaves on campus as well. Converting those to electric are things that'll show up here in this first phase of implementation. So here, again, is the schematic, and the first thought was that, well, we could take the step toward district hot water by taking steam and making hot water in our heating plant and building out some backbone components for distribution. So the first phase here is to do just that. Let's set ourselves up with a hot water distribution system. And then in parallel with the NGIC building and the linear work that we plan to do across campus to connect that domestic water project, let's put some EN 253 pipe in and get the backbone of that hot water distribution installed. So there's 1,250 feet of that is included in our first step toward implementation. And then that would allow us to pull steam distribution back to about 50% of the tunnel length and significantly changing our heat loss through the tunnel when it is operating. And then also taking a stab at that culinary steam in the food science building, getting that converted to electric. Moving forward into a second phase, more substantial investment here, but with the success of the first phase, we felt we could build momentum with the administration and finish that steam to hot water conversion. So the first step here was to finish the district hot water plant at the heating plant and make those final building conversions from steam to hot water that would allow us to pull the steam distribution back all the way to the heating plant, eliminating any losses through our tunnel. And just anecdotal information about our steam losses. In August, we're consuming about 200 decatherms of natural gas, and really there's no demand on the system at that time. So it's a significant amount of usage that we're trying to avoid. Because at this point with the retrofit of the mechanical systems in food science and the NGIC both of those projects bringing about 1,000 tons each of chilled water capacity, we felt that it was the right time to build a backbone for a chilled water network in the abandoned steam tunnel. So the plan is to reuse the steam tunnel for that purpose. So that's highlighted on the sketch there as the blue line. It's sort of the first step toward our distribution for chilled water. And we would dispatch chilled water more efficiently utilizing the 2 machines that were proposed to be installed about the same time through the parallel projects. Stepping into a third phase, this is where the geothermal component starts to play a role in our master planning here, with the first 33% of geothermal capacity added to our system, as well as a replacement of one of our 750 horsepower boilers with a combo heat pump chiller unit. We're calling it heat pump chiller unit 1. And then using supplemental heat to continue from the other 750 and the other 350. Supplemental cooling coming from those 2 machines that are located in food science and that NGIC building. Also making the extension of chilled water to link our third and final significant chilled water user, that Barton lab building. So this really completes sort of the backbone of the chilled water system and gives us the chilled or the geothermal component as well. Our fourth and final phase, and just a couple of benchmarks here relative to where we started. At the end of this phase, we're projecting a significant reduction in natural gas usage, right? You can see there about 2,000 decatherms. That's down from 67, and a fairly significant increase in power usage, but interesting thermodynamics working there. It is not proportional. The expected annual cost of energy here built out is less than where we are today. This phase would add 100% of the geothermal capacity, also complete the replacement of the boilers with the heating cooling units 2 and 3, but recognizing some of the challenges with our proposed hot water temperature and our greenhouses. We do recognize that we will still be burning some hot natural gas, and we need some sort of boiler to provide supplemental heat on design days. Very minimal part of the year, but important nonetheless. So our final heating plant configuration would still include some sort of modular boiler component. And also at this phase, we would finish our chilled water distribution to some of the remote buildings on campus from that backbone that we laid in the earlier phases. So there's all 4 phases. This chart here shows the incremental reduction in greenhouse gases associated with each phase. And as I overlay onto this chart, you can see along the time horizon on the bottom of the chart by year, there is a significant reduction as we apply each one of the phases, and the results are programming that achieves the 40% reduction goal by 2030, which meets the New York State and university reduction goals. And then with the addition of the geothermal, there is projected to be an 85% reduction in greenhouse gases, meeting that 2050 goal. And the time scale here is flexible between implementation years. So there's, if you will, that the point at which we move forward with phases 3 and 4 can slide to the right on the chart. So how did these projects overlap with some of the campus projects? This chart intends to kind of illustrate that here. We've got the fire protection improvements, the NGIC construction, food science renovation, and those end-of-life upgrades, all kind of laid out here on the scan chart. And we've identified a window to maximize is really where we are right at this moment. So as we start overlying those other projects here, you can see that things are lining up for us to be moving in the direction that we are right now, with a commitment from SUCF. There are State University Construction Fund partners. They've made a 100% commitment for design, which is underway. That'll take us through all 4 phases of the implementation project. And with design-ready projects, our anticipation is that we'll be successful in building at least phases 1 and 2, and moving forward that time scale instead of out farther toward 2050. We really see as a mission for CALS, for the college, that building a demonstratable geothermal solution for our campus would be beneficial to the state and to any other end users. So I think that's it, Sue, for me.
Right on time. All right. Does anybody have any questions? Oh, we got troublemakers over here. Sure, just, do we have a microphone we could hand?
Hello? Okay, this question's for Scott. As you're going through your design process and your phasing, switching to hot water, where did you start, and then where are you planning on finishing with the temperature of that hot water? Are you initially going right to low temp, or are you kind of transitioning that as you go through to get to 100% GEO?
We have some greenhouses, and the concern is there that we really can't drop below 190. So the thought there is that we would try to hold at about 180, and with a goal of going to 150 if things were possible. But our initial step is to go to 190 to 180.
Hi, I'm Jean Bergman from Sane Energy. I'm kind of stuck on the greenhouse thing too. Have you thought about storing heat in the summer under the greenhouse in the slabs that would then be able to be recaptured and used in the winter?
Lots of ideas are popping up, and that is definitely one of them. We're also thinking that there is probably a refrigeration process here that could be used to step up the temperature. Instead of running the whole district at 190, perhaps we could, because we are not distributed with our greenhouses, are fairly centralized, that we could run at 150 and then step up through heat pumps to provide a higher temperature water. That's probably the leading idea.
My name is Charles. I just want to ask a question. Manhattan and Brooklyn and New York City metropolitan area sits between 2 rivers. I'm just wondering, at which point is technology going to be available and it's going to be permitted to use the thermal capacity of massive amount of water just passing through?
Sure, I can take this one. Yes, that's a great question. So there are some buildings in New York City that already have permitting rights to extract the water and use that for cooling and heating. We do have examples in our program where that is already being leveraged. You could go on our website and take a peek at our Brookfield Place project. That's a large 4 commercial buildings that are taking advantage of their existing permit to use that for heating and cooling. And you are right that there probably are going to be challenges with permitting new buildings going forward, but certainly something that we take into consideration both in the city and upstate as well. There can be challenges in the colder climate and leveraging moving cold water. Sometimes it's not worth the extra challenges that come along with it, but certainly something that should be considered, or any other opportunistic thermal resource that might be near a project site. I'll go here, and then you have to go back to the other side of the room.
Question for Scott. When is NYSEG involved, I guess, in the planning process for kind of this large decarbonization project from a utility perspective?
We've recognized that our substation's a little undersized. One of the primary reasons why we're working with them now on some energy savings to really minimize how much more power we'll need. But through the design phase, they'll be big partners for sure. And as I mentioned, SUCF, our funding source, is providing us with 100% of the design, so we're going to be rapidly moving in that direction.
Hi, my name is Fleming. I had a question regarding PON 5614. I guess one, what qualifies as large-scale thermal, and two, do state office buildings qualify for these cost-sharing opportunities?
Sure. I'll take your second one first. Yes, absolutely. What qualifies for large-scale thermal falls into a couple of categories. So large-scale thermal is a term that we're using to encapsulate large buildings that are at least 150,000 square feet of conditioned space, or groups of buildings in aggregate that are at least 250,000 square feet of conditioned space. And that's not reliant on the thermal solution, so that can be a network solution, or that can be standalone solution on a single property. But those are the two major buckets. So large buildings, 150,000 square feet, or multiple 250,000 square feet.
There's also one more question. State office buildings?
Yes, yeah, so state office buildings would absolutely be eligible. Anybody on this side of the room that wants to ask Max a question? Okay, we'll come back to you, Talal.
Hi, my question's for Scott. My name's Chase. I'm from Ramble. I'm just curious on, I saw in your phasing plan you're doing 33% capacity and then 100% geothermal, right? How are you addressing, balancing, or you're sizing it for, the full annual cooling load? Because I imagine you're heating dominant, right? How are you addressing any, geothermal balancing? Because I imagine that you're going to be extracting a lot more heat from the ground.
Yeah, great questions there. The thought here is, let's find a path forward to full implementation with a spirit of demonstration and experiment. So the 33% capacity was really chosen more on price point than on the thermodynamics involved here. So there'll be some refinement of that exact percentage, but we want to have a demonstration component, right? So we can be leaders and show the path forward.
Just the follow-up question on the program. So when you mention non-networked large-scale thermal projects, does the cluster of buildings need to be in the same vicinity, or can it be like multiple sites?
Yeah, so single campus or contiguous properties. So it has to be connected together. So if a real estate developer has a portfolio of buildings and one is in Potsdam and one is in New York City, we hope that their buildings are big enough to submit those projects separately, because that would not constitute a single campus, or that would be a very long network of pipes. But hey, we're interested in unique opportunities. So.
But they don't have to be connected together.
They do not have to be connected together.
Okay,
Correct. Yeah, it
Awesome.
can be multiple buildings on a single site,
awesome. Thank you.
as long as it's the best technical and economic
Yes.
solution that they're putting forward.
Yes.
Mike, you thought you were going to get off the hook here, but this one's for you, because we now know that the opportunities right now with campuses, medical campuses, college campuses, that's why we have you here. If you can let the folks know sort of the magnitude of Northwell's portfolio in terms of total square footage that you're looking at. And I know when we've talked before, again, you're focusing on heat recovery, waste heat recovery. What are you looking to recover the heat from and take to?
Yeah, that starts to get deep, but our campuses cover probably about 25 million square feet without some additional properties that are joining, so we'll get up to 30 million square. But there's a lot of wasted energy in hospitals. Back to the reference I made about the simultaneous heating and cooling, but also the requirements that we maintain temperatures between 72 and 68 degrees, that we maintain a certain RH. So if you take the BTUs going into the building, we're about 67% natural gas, fossil, into the building. So switching that percentage significantly requires a lot of thermal work. And that thermal balancing is one of the ways that we're looking at is thermal storage. But how do we just manage through entropy wheels, through other metrics of moving the air around, how do we balance those thermals? It gets challenging because of patient needs and employee concerns and visitors, but we're balancing.
It's not a trick question, but a follow-up. We've talked about the term thermal reengineering. If you can explain what that concept is.
Yeah, I think we're at a maybe a sea change in how we're doing things. Like a lot of the earlier initiatives have been identified where they're part of the book of business. We're doing those, but we're starting to get into that point where there was 25 years ago re-engineering the corporation. And it was just taking a look at how do we take the norm, the existing conditions and paradigms, and alter them. And I think what we're looking at on the thermal side is that. We just talk about 550 people here today, whereas I'll bet 5 years ago we didn't have that quantity of folks. So we're starting to get a lot more collaboration, a lot more coalition building. We're anticipating needs for the future. And I think with coupling the challenges with some of these solutions and coming up with, well, hey, we didn't think about that before. Getting back to Peconic Bay, what we're analyzing right now, the Glen Cove 60-year-old project was pretty easy. We're pulling water from 400 feet down, circulating at once, and dropping it back on the other side of the campus. But balancing the closed loop becomes a real challenge. So that's what Charlie's doing for us. And we're identifying how we best balance, where the heat exchanger is going, what air handlers can we integrate into this, how do we perhaps add thermal storage reservoirs, like in the case at North Shore, to give us a buffer, similar to what we've been doing for decades in water systems. Why do we have water towers? How do we start to look at things a little bit differently? And I think that's the concept of the re-engineering.
Okay, I think we're at time.
One more question,
Oh,
and
one
then
more question, okay.
we'll wrap up here.
Sure, only if it's an easy one.
Well, I mean, hey, Mike. Just curious, I hear experimental, I hear showcase, I hear new ways. I'm just curious, are you guys looking at wastewater as an energy source for your thermal transfer?
Yes.
In Cornell and also Northwell?
Yes, but one of the biggest challenges, I think, to that, and I did want to reference or talk to you about this, is there's a lot of wipes that get used in patient care, and we have broken macerators attached to 150 horse motors. That takes a lot of mass to do that. So I think we need to look at how do we manage this specific wastewater and channel it appropriately, because sure, there's plenty of thermal energy right there, but how do we specifically manage that?
We'll have to bring the main campus facilities folks in for the next one to answer your question there, but we're probably too small at AgriTech to consider it.
Okay. Thank you, everyone. Enjoy the rest of the conference.